Hello and welcome to the class on rocks. Okay, I am Laura Lewis for Key Stage 3 and some Key Stage 4. Okay, so let's get to the next slide. So let's have a look. So we're going to talk about the formation of the Earth first of all. So we're going to be a long journey today from the formation of the Earth to rocks. So before the Sun and the Earth, there was a large cloud of gas and dust called a nebula. Okay, so nebula is gas and dust cloud in space. When we say they're very large, they are bigger than the whole solar system. Okay, so all of the elements that went to make up our Earth are actually contained in the nebula. They made the Earth and the Sun and the other planets. Okay, so this is really the origin of all the rocks. Okay, I think it's important to mention this is actually where it comes from. So a nebula will collapse by gravity to form a star and planets. Okay, in our case, it formed our sun, and the remaining gas and dust formed our planets. So that picture there is called the Orion Nebula. So it's in the constellation of Orion. Okay, so it is it's in the sky in the winter time in the UK where I'm filming this. And you can actually see the stars forming in it still now. So the little blue stars you can see there, they are kind of got like a fuzziness around them. So that fuzziness is the remaining gas and dust from which they were formed. Okay, so the sun formed in a very similar way in a nebula. Okay, so let's go back to that. So let's have a look at the early Earth. So we're going to talk about the solid Earth for this video. I've made a different video about the atmosphere, so just going to go over solid Earth. So the rocky inner planets, Mercury, Venus, Earth, Mars, form nearer the Sun because the heavy elements left over from the Sun's formation remained closer to the Sun. So when the Sun formed from the nebula, there was a disk of gas and dust swirling around it. The heavier elements remained closer to the Sun, okay, and the lighter ones were flung further outwards. So the rocky planets, or terrestrial planets, so they've got rocky surfaces, they stay nearer the Sun than the gas giant planets. So the gas giant planets, Jupiter, Saturn, Uranus, and Neptune, actually have rocky cores, but they've got lots of gas accumulated around them as they formed in the colder part of the solar system. So the reason why the Earth is solid and rocky, okay, with no extensive atmosphere, so no atmosphere like Jupiter, because it formed nearer the Sun, and it was also hotter. Okay, so we're made of rock and metal, so let's concentrate on the Earth for the moment. So let's look at an overview of the Earth, okay, before we go into rocks in more detail. We need to look at what the Earth is made from. So again here, the heavier materials, the metals, sunk deep into the Earth. So the inner and outer core are both made of iron and nickel, but they differ in their state, meaning that the inner core is solid and the outer core is liquid. The inner core is solid because it's under a lot of pressure, okay? And the metallic core is actually the reason for our magnetic field, okay? So the reason why we've got a magnetic field is due to the iron and nickel core. So the lighter, in comparison to the metal, rocky material floated towards the top and formed the mantle, which is made of semi-molten rock. It's not entirely molten, the mantle, and the crust made of solid rock. So we'll look at that in a bit more detail here. So the composition of the Earth in a bit more detail. Okay, we don't need to know too much more about the inner and outer core. Just know they're made of iron and nickel, and that they are responsible for the magnetic field. But we can look at the mantle in a bit more detail. Okay, it's split into the semi-solid mesosphere and the asthenosphere. Okay, the tectonic plates you may have come across before sit on the mobile, which means it can move, asthenosphere. The crust that we stand on is part of the lithosphere. Okay, it's part of the lithosphere. So this is the part we stand on and is a solid part of the Earth. Okay, So let's have a look at this diagram for a moment. So this is actually the elements from the periodic table shown as their abundance, so their amounts in the Earth's crust. So all of our rocks are made from elements. So this is an interesting diagram. The most common is oxygen, and our planet could actually be classified as an oxygen planet. It might be surprising until you see the next one down. So O for oxygen, Si, silicon. Okay, silicon. So silicon and oxygen together make silicon dioxide, which you might know as sand or quartz. And most of the Earth is made of quartz, and other rocks are built on quartz. So quartz is a mineral, okay, and we'll talk about minerals and rocks, okay, in a little while. And then aluminium and iron, and then calcium. So you can actually have a look and pause that diagram to see, but oxygen and silicon are most common there. So the three main rock types. So you've got igneous rocks, so born of fire, that the name means, volcanic rocks. Okay, so you'll go into a bit more detail about different types soon. So born of fire, volcanic. So we've got basalts, we've got granites. Okay, on the video on the rock cycle, okay, which I've made, go into a bit more detail about their formation, but this one we're looking over for rocks. Sedimentary, made sediments that have been compacted, such as mud and sand. So mudstone, sandstone, okay, are sedimentary rocks. Metamorphic, so changed rocks. So sedimentary or igneous rocks that have been changed or metamorphosed, in other words, changed under heat and or pressure. It could be both, it could be or. Okay, so look at the rocks in the UK. Okay, it's quite interesting. So how old the rocks are. So the oldest rocks, so Paleozoic is the oldest, so it goes from, this is the oldest to the youngest. I know it's kind of strange, it goes from oldest to youngest this way. This is the oldest going to the youngest, and also separates into sedimentary, metamorphic, and igneous. Okay, so igneous is red. So you can see lots of igneous rocks in Scotland, lots of igneous rocks down near Devon and Cornwall, and lots of young, so Cretaceous and Cenozoic, so you say that, younger rocks around London. Okay, so it's kind of, as a general rule, the rocks get younger this way. Okay, in the UK, that's an interesting observation. They get younger that way. So you can have a look at what type of rocks are around where you live. Okay, so we're going to look at useful rocks. I'm going to look at a bit more rocks in general, and I'm going to look at some useful ones. Okay, so the minerals that we use and other substances are actually taken out of rock called ores. Okay, and most metals, apart from a few, silver, gold, and platinum, are found chemically bonded to other atoms. So this compound makes up a rock called an ore. So the metal bonded to another element makes up the ore. So a definition is an ore is a rock that a metal can be extracted, so taken out from. So for example, copper has a few different ores. So one is chalcopyrite, which is made, as pictured on the bottom there, it's made of iron, copper, and sulfur, chemically bonded. And copper tends to form very pretty ores. Another ore copper is malachite, so the jewelry in the top there, the necklace. So copper carbonate, so malachite is copper carbonate, often used in jewelry. Okay, so this is about something at the top there, about chemically bonded. I said most metals, apart from silver, gold, and platinum. So that necklace is probably, the metal probably gold. Okay, so lots of jewelry, okay, you wear silver, gold, and platinum. They're actually used as jewelry because they don't react with anything, so they'll last a long time. So you can, you have to make sure your jewelry is pure gold or pure silver, okay, so that you can actually get it wet. Okay, if it's something else, it can obviously, it can corrode. So it reacts with water and the atmosphere to corrode. Okay, that's why it's used, because obviously we have wedding rings and things made of gold. Okay, so that they don't corrode or they don't react over time. Okay, here's some in detail. So cassiterite, they're all quite pretty in their own way, aren't they, rocks? Cassiterite is an ore of tin. Sphalerite is an ore of zinc. Galena is an ore of lead. Bauxite is an ore of aluminium. And hematite is an ore of iron. If you look at that word hematite or heme at the beginning, you may recognise it from hemoglobin. Because hemoglobin, our blood's got iron in it, and that word means heme, H-A-E-M, means iron. So it shares a common prefix of the word there. Okay, in the Natural History Museum in London, you can see all huge samples of these rocks. I remember seeing them. It's always worth to go and have a look in the mineral gallery, rock and mineral gallery, to see these. Okay, yeah, ores generally quite pretty rocks. Okay, more ores again. So rocks can contain many different elements and compounds. So if there is enough metal in the rock to make it economical, so that means the metal is worth more than it is to extract it, it's called an ore. Okay, so lots of rocks have metals in them, but they might not be economical to extract. So that means that it's not worth it, and it take more money to get it out. So autunite, top, and granite, the bottom picture, both contain uranium. It would cost too much money to extract the uranium out of the granite, so granite is not an ore of uranium, but autunite, the top one, contains more uranium that is profitable to extract, so it is an ore of aluminium. Okay, so it's an ore of it's an ore of uranium. Sorry, they're both uranium, not aluminium. So they're both granite is not an ore of uranium, but autunite is an ore of uranium. So the words are correct there, uranium. So how are they extracted? So it depends on how reactive it is. So we've got a crossover here with chemistry. Okay, the left shows a reaction series. You may have seen this in chemistry. It tells us how we can extract the metals from their parent rocks. If a metal is less reactive than carbon, the ore can be extracted by heating it with carbon. Okay, so zinc, iron, lead, copper are less reactive than carbon. If it is more reactive than carbon, so aluminium, magnesium, it cannot be extracted by heating with carbon. If they are more reactive, they are extracted by electrolysis, and there'll be other videos about electrolysis. Okay, so briefly, a more reactive element will displace or kick out a less reactive element from the other element it's chemically bonded to. So carbon is more reactive than iron, so iron can be extracted from its ore, hematite, by heating with carbon. Iron oxide plus carbon goes to iron plus carbon dioxide. Okay, so here's a brief. So any metal that is below carbon, again, the reactivity series can be displaced with its compounds. So don't worry too much for this video about the equations. We'll cover that more in chemistry, but we're just saying obviously that these are rocks. So copper oxide and lead oxide are rocks. Okay, so copper oxide plus carbon goes to copper. We extracted the copper from it, plus carbon dioxide. You can also extract carbon with lead oxide. So lead oxide plus carbon goes to lead plus carbon dioxide. So just to be sure what carbon is, so you may know carbon is charcoal that's used in barbecues. It can be made from burning wood. So ancient people had access to carbon. So ancient people had access to zinc, iron, lead, and copper, but not magnesium, aluminium. They need technology to advance to get those. Okay, so comprehension check. So that I would encourage you to write these down, okay, and to look back at what we talked about to check your answers. So you can sort of pause the screen and you can answer them. Okay, here are the answers. So name 3 metals that are not found in ores. Gold, silver, and platinum. These metals are very unreactive and do not combine with other elements. Okay, so they are found on their own. And the definition of an ore is a rock contains a metal that would be economical to extract. Name 2 metals that could be extracted from their ores by heating with carbon. Okay, so copper, iron, and zinc. Copper, iron, zinc, and lead are less reactive than carbon, so can be heated with carbon to extract them from their ores. So uranium can be used in nuclear power stations. Name an ore of uranium. Autunite is an ore of uranium. So is pitch blende. We didn't mention that, but pitch blende is another one. Often there's more than one. Okay, so this one is spot mistakes. So I won't go through, well, I'll show you the answers, but I won't go through it, okay, because it's needed, you need to carefully rewrite these sentences. So that's something to do. Okay, so pause it and rewrite the sentences. Okay, here's the answers. Now for a last sort of quiz, a bit of fun. Okay, I'm going to show you pictures of rocks. These are actually from my own collection. These are photographs I took. Okay, and you're going to try and name the ore from the photos before. It's just a bit of fun. Okay, you won't be examined on this, but it's a bit of fun. Okay, to you sort of think about in real life these things do exist. Okay, so roof tiles can be used. The answers will be at the end. I'll go through them all, and then the answer will be at the end. Hint: roof tiles can be used to make the metal contained in this ore. There's the other hint, helps you a lot here. Oh, this is one of my necklaces. Now, the metal contained in this ore is used in like electrical wires. Sometimes you might be able to get it without thinking about the ore. 3, this metal contains an important mineral your body needs. Ooh, also known as, this is a rock, okay, also known as fool's gold. Okay, so you try and name the rock and what it contains. You've got sort of a bonus one there. And then a bonus round, which elements do you think these contain? One is an ore. Okay, it's interesting. Again, these are just for my collection, so I took photographs of them, quite interesting to look at. Okay, first one, Galena, an ore of lead. Remember roof tiles, old roof tiles anyway. So Malachite, ore of copper. Sphalerite, ore of zinc. Our body doesn't need zinc. Pyrite, it's actually an ore of iron. You might have some pyrite, it's quite common, a collectible rock, it's quite pretty. 5, so the yellow one, sulfur. It's actually an element, sulfur, because they're not all ores. 6 is a copper ore. I actually don't know what that is. Somebody gave it to me. They found it outside somewhere. And it's definitely an ore of copper because it's green. Let's sort of see if we know that. 7, it's not an ore. It's silicon itself. Okay, so silicon. That's interesting. Okay, right. So thank you for listening today. And I hope to see you in another video. Thank you. Goodbye.